Hello friends, in my previous videos I have started discussion on feedback amplifier, and in my this video I am going to show you how to realize the feedback block for a feedback amplifier for gain less than 1. Okay, so let us discuss. This is the scheme of negative feedback. Here input signal is entering through this point, okay, and here H is the feedback block through which the feedback signal is entering, and here the feedback signal is subtracted from the input signal, and here we get the signal E as which is equal to xi, that is input signal minus the feedback signal, or fs, okay, feedback signal, and then it is passed through the gain block with gain factor G, and we get the output. This is the scheme of the negative feedback. Now, in my previous video, I have told you that the H may be 1 by 10. With assuming H equal to 1 by 10, I have solved one numerical. So, you may think for this gain, we can use BJT or MOSFET amplifiers, which gain factor can be 10, 20, 30, 100, 1000, etc. Any value, or other by op amp it can be increased much amount. So basically this gain block or amplifier block we can easily realize by one amplifier circuit. But how we can get gain as 1 by 10 or fraction value, or how we can attenuate or weaken the strength of a signal? Today in this video I will show you how to realize this block, H block or feedback block. Okay, see, so for attenuation purpose we use attenuators. Okay, it is a vast topic in electronics engineering, but I will show you just some important points and some gist or some overview of this topic. Okay, what is attenuator? Attenuator is a device consisting of an arrangement of resistors which reduces the strength of a signal. Okay, if only resistors are used, that means no phase shift in between input and output, and that will become only a passive attenuator. You all know these concepts. See here, I have shown one passive attenuator with voltage divider biasing circuit. Okay, voltage divider circuit. See here, R1 resistor is there, with it R2 resistor is series connection is there, and we are taking the output voltage across the R2, and here it is input voltage V in. Okay, so we know this is the expression for the voltage divider biasing, where V output equal to V input into R2 by R1 plus R2 volts. Now R2 by R1 plus R2, see this thing, this factor is less than 1, so obviously V output is less than V input. Okay, clear? It is clear from the graph, from this circuit, that across R2 if we take the voltage, then obviously it will be less than V input, because across R1 some voltage drop will be there. So basically here it is used to reduce its input voltage by some amount. Okay, so we can use the voltage divider circuit to reduce the input voltage by some amount. We can apply a voltage divider circuit to weaken a signal in such a way. Suppose this is the amplifier block, and we connect the amplifier block with the voltage divider circuit. This is the voltage divider circuit. R2 and R1 are series connection is there, and we are taking the output voltage across the R2, and then if we connect the output of R2, that means we take the output voltage across R2 and connect it with a speaker or any next block of circuit. So basically what is happening, the signal which is present across R2 is weaker than the signal which is we are getting from the amplifier. We are getting a high voltage from the amplifier, but we are weakening, or we are reducing the voltage, or we are weakening the signal strength. Okay, so voltage divider circuit basically acts like a attenuator, or to attenuate or weaken a signal we use this block. Okay, so it is clear, as the output is less than input, then obviously for this case gain is less than 1. Okay, so as for this case gain is less than 1, So this is one kind of circuit which can be realized for this H block. Okay, so as I mentioned that for H block the gain is 1 by 10. How gain can be fraction? We know gain means obviously it is greater than 1. Okay, means we are giving less amount of input, we are getting large output. But from attenuator circuit we can get gain which is less than 1. So in our previous video, as we solved one numerical based on assuming the gain factor of the feedback block as 1 by 10, so that can be realized by the simple voltage divider circuit. This is called L-pad attenuator. Similarly, T-type and many other attenuators are there. I am not going in that detail, but in this way you can realize the attenuator. And one very important information, that for feedback circuits, like for negative feedback, most of the cases the feedback circuits are purely resistive type. Okay, and most of the case they act like a attenuator. So basically for feedback circuit, this H block is, for most of the case, this is resistive type and these are attenuators. So for this H, the gain you can assume for general case like it is less than equal to 1, and this is purely resistive, so no phase shift is there for this block. Okay, so if the feedback block, that is if the H block is purely resistive, then we get a lot of advantage for that negative feedback, that I will discuss while discussing the effect of negative feedback in reduction of frequency distortion and the effect of negative feedbacks in some other cases. Okay, so if you just for the time being you just keep it in mind that if the H block is resistive type, then there are a lot of advantages, and if it is an attenuator, then obviously gain can be less than or equal to 1. Okay, this thing I will take this concept in my next videos, and I will show you some more concepts. This is all for this video. Thank you for watching.